Have you ever wondered why Ford's most legendary racing engine got such a weird nickname? The side oiler. Sounds more like a kitchen appliance than a fire-breathing V8 that dominated Le Mans and terrorized drag strips. Well, turns out that odd name holds the secret to why this engine became virtually unbeatable in endurance racing. Today we're counting down 20 shocking secrets about the Ford 427 side oiler that even die-hard blue oval fans probably don't know. From hidden engineering tricks to bizarre production stories, these revelations will completely change how you see this iconic power plant. And trust me, number one is going to blow your mind. But before we dive in, hit that like button and subscribe if you love classic American muscle. It really helps the channel grow. The side oiler nickname came from its unique oiling system, which fed the crankshaft first via a separate gallery along the block's left side. Think about that for a second. Every other engine of the era sent oil up to the valve train first, then down to the crank. Ford flipped the script completely. They literally machined a separate oil passage running along the driver's side of the block. This wasn't just different, it was revolutionary. The gallery ran parallel to the crankshaft, feeding each main bearing directly before the oil went anywhere else. Engineers called it priority oiling. Racers called it genius. This side feed design prevented oil starvation at high RPM, crucial during 24-hour endurance races like Le Mans. Picture this. You're screaming down the Mulsanne Straight at 180 miles per hour, 6,000 RPM for minutes on end. Traditional engines would lose oil pressure to the bottom end. Bearings would starve, engines would explode. But the side oiler kept pumping that liquid gold right where it mattered most. The crankshaft stayed happy even under the most brutal conditions imaginable. That's why GT40s could run flat out for an entire day, while Ferraris were dropping like flies. Ford created it to solve bearing failures in early top oiler 427 FE engines used in NASCAR and GT racing. See, the original 427 had a problem, a big problem. The top oiler design sent oil up through the cam and heads first. By the time it reached the crank bearings, pressure had dropped significantly. NASCAR teams were spinning bearings left and right. Road racers were even worse off. Those long, high-speed corners just murdered the bottom end. Ford engineers went back to the drawing board in 1964. They knew they had the power. The 427 was already making serious horsepower, but it couldn't survive endurance racing. The solution came from an unlikely source: marine engine design. Boat engines dealt with similar sustained high RPM loads. Ford borrowed their priority oiling concept and adapted it for racing. The side oiler was born from pure necessity. Without those bearing failures, it might never have existed. Racing really does improve the breed. The 427 was actually 425.98 cubic inches, Oversquare with a 4.23-inch bore and 3.78-inch stroke. Nobody talks about this. Ford rounded up naturally. Marketing loved those round numbers. But the real displacement tells you something important about this engine's character. That Oversquare design wasn't accidental. Big bore, short stroke. It's a recipe for high RPM power. The large bore allowed massive valves. We're talking 2.19-inch intakes. The short stroke reduced piston speed at high RPM. Less stress on the rotating assembly. This combination let the side oiler rev higher than most big blocks of the era. 7,000 RPM was common in racing trim. Some NASCAR teams pushed 8,000 with special valve springs. Compare that to a Chevy 454. Longer stroke, lower rev ceiling. The Ford gave up some low-end torque, but gained a screaming top end. Perfect for road racing where you kept the revs up. That Oversquare design was key to its racing success. It debuted in 1965 as the race-spec evolution of Ford's FE family, which stood for Ford Edsel. Yes, Edsel, the car that flopped so hard it became a punchline. But the FE engine family was brilliant. It started in 1958 with the 352. By 1961, Ford had the 390, then the 406. Each generation pushed the envelope further. The 427 was supposed to be the ultimate FE, and the side oiler was the ultimate 427. Ford introduced it midway through the 1965 racing season. Teams had been begging for a solution to the oiling problems. When the side oiler arrived, everything changed overnight. Holman Moody got the first batch. Their cars immediately stopped blowing engines. Word spread fast through the racing community. Everyone wanted the new miracle motor. Ford had accidentally created a legend, the FE family's crown jewel. From Edsall's ashes came Ford's greatest racing engine. Number 16. NASCAR forced Ford to build at least 500 side oilers for homologation, making it technically a production engine. This is where things get interesting. NASCAR's rules required manufacturers to sell what they raced, 500 units minimum. Ford had no intention of mass-producing side oilers. They were expensive, complex, totally unsuitable for street use. But rules were rules. So Ford did the bare minimum. They built exactly what NASCAR required, not one more. These homologation specials went to select dealers. Most ended up with racers anyway. The average buyer had no idea what they were getting. Imagine walking into a Ford dealer in '65. You could theoretically order a side oiler in your Galaxy. Few did. The option was barely advertised. It cost a fortune, but it was there on the order sheet. A full race engine hiding in the passenger car catalog. That homologation requirement gave us one of the rarest production engines ever built. The block featured cross-bolted main caps with 5 bolts per main bearing for incredible bottom-end strength. This was aerospace-level engineering in 1965. Most engines used 2 bolts per main cap, maybe 4 on the center main if you were lucky. Ford went completely overboard. 5 bolts per main cap. 2 vertical bolts went straight down as usual, then 3 horizontal bolts came in from the sides. They literally locked the main caps to the block walls. It was like a bank vault down there. This design came from Le Mans testing. 24 hours at maximum power revealed every weakness. Standard main caps would walk around under extreme loads. Bearings would spin, blocks would crack. The cross-bolting solved everything. Those caps weren't going anywhere. Ever. NASCAR teams loved it. They could run ridiculous compression ratios, massive nitrous shots, aggressive cam timing. The bottom end just laughed it off. Modern race engines still use similar cross-bolting. Ford pioneered it with the side oiler. Factory rated at 425 horsepower, dyno sheets often showed 480-plus horsepower with proper tuning. Ford was sandbagging, big time. That 425 rating was with terrible exhaust manifolds, a mild cam, conservative timing. It was deliberately understated for insurance reasons. Put headers on it, advance the timing, jet the carbs properly. Suddenly you had nearly 500 horsepower. Racing teams discovered this immediately. Stock side oilers were making more power than advertised race engines. Shelby's crew blueprinted one and got 520 horsepower on pump gas with hydraulic lifters. The potential was staggering. Some drag racers saw 550 with good heads and a cam. The factory rating was a joke. Everyone knew it. Insurance companies eventually caught on. That's partly why production ended. But for a brief moment, you could buy 500 horsepower over the counter. Ford just wouldn't admit it officially. Its real fame came from powering the GT40 Mark II, which won Le Mans in 1966 and 1967. This was Ford versus Ferrari, David versus Goliath, America versus Europe, and the side oiler was the slingshot. Ferrari had dominated Le Mans for years. Their engines were works of art, sophisticated, complex, temperamental. Ford showed up with a big, brutal American V8. The Europeans laughed. Until the race started. The side oiler's simplicity was its strength. It just kept running. Hour after hour. Ferrari's engines were faster in spurts, But they couldn't maintain that pace. The side oiler could run flat out indefinitely. That priority oiling system was the difference. In '66, Ford finished 1, 2, 3. Total domination. Ferrari was stunned. In '67, Ford won again. The side oiler had conquered Europe's most prestigious race. Twice. It proved American engineering could beat anyone. The racing world would never be the same. Shelby also dropped side oilers into Cobras, turning them into nearly unstoppable road racing weapons. Take a lightweight British roadster, stuff in a massive American V8. What could go wrong? Everything. But it worked. The 427 Cobra was completely insane. Side oilers made it legendary. Shelby built about 300 of them. Each one was basically a street-legal race car. The combination was devastating on road courses. That high-revving side oiler perfectly suited the Cobra's character. Light car, big power, priority oiling for sustained high-speed cornering. It was unbeatable in SCCA racing. Privateers were beating factory teams. The side oiler Cobra became the ultimate giant killer. It embarrassed Corvettes, humiliated Jaguars, made Ferraris look slow. The engine was so dominant that racing organizations started banning it. Too fast, too reliable, too successful. Even today, an original side oiler Cobra is the holy grail of American racing. The oil trick was the separate side gallery that prioritized crank and rod bearings before cam and valve train, unheard of at the time. Let me explain why this was revolutionary. Every engine needs oil pressure, but where that pressure goes first matters enormously. Traditional engines routed oil up through the center of the block. It hit the cam bearings first, then the valve train. Finally, it reached the crank. Under racing conditions, that's backwards. The crank bearings take the most abuse. They need oil first. Ford's solution was elegantly simple. Machine a new passage, route oil directly to the mains. Skip everything else initially. The cam and valve train got oil through a secondary circuit. They didn't need as much pressure anyway. This priority system was genius, but it required completely redesigning the block. New casting molds, new machining operations, extra manufacturing steps. That's why it was expensive. But for racing, it was worth every penny. At 6,000 RPM, that priority oiling change meant survival, while previous top oilers would lose pressure and spin bearings. Here's what happened inside a top oiler at high RPM. Oil pump pressure peaked around 70 psi. By the time oil traveled up through the cam galleries, down through the heads, back through the lifter galleries, pressure at the mains dropped to 30 psi, maybe less. That's dangerously low for racing. Now the side oiler, at the same 6,000 RPM, oil went straight to the mains, full 70 psi, no pressure drop, no starvation. The bearings stayed cool, properly lubricated, happy. This difference was everything in endurance racing. A top oiler might survive a drag race. Quick burst, 13 seconds of abuse. But Le Mans, Daytona, Sebring? Forget it. The side oiler could run 6,000 RPM for hours, days even with proper maintenance. NASCAR teams reported zero bottom-end failures with side oilers. That was unheard of in 1965. Ford had solved the unsolvable problem. Ford even cast a tiny 427 into the block skirts to identify true side oilers from Service 390 and 406 blocks. This little detail drives collectors crazy today. Real side oilers had those numbers cast right into the block. No 427 marking, not a side oiler. Period. Fake side oilers are everywhere now. People take regular FE blocks, drill some passages, call it a side oiler. The casting numbers don't lie. Ford also used specific casting codes, C5AE-B for early blocks, C6ME for later ones. But the 427 number was the dead giveaway. It was tiny, about half an inch tall, easy to miss if you didn't know where to look. Right side of the block near the oil pan rail. Some restorers accidentally grind them off during rebuilds. There goes half the value. Those three little numbers are worth thousands to collectors. It's the difference between genuine Ford racing history and just another big block. Aluminum medium riser heads and high-rise intakes gave airflow rivaling exotic race engines of the day. Ford offered three different head designs: low riser, medium riser, high riser. The medium risers were the sweet spot, perfect balance of airflow and reliability. These weren't just good for a pushrod V8, they were good, period. The intake ports were huge, exhaust ports too. The combustion chambers were designed for maximum efficiency. Ford spent millions developing them in their racing program. With the right intake manifold, a medium riser side oiler could outflow a Chrysler Hemi. Think about that. The mighty Elephant was legendary for airflow. The Ford matched it with conventional wedge chambers. High-rise intakes were works of art, dual quads sitting way up high, rivers of aluminum feeding those massive ports. It looked like something from a drag boat, because it basically was. The combination was intoxicating, literally. These things drank fuel like Prohibition was coming back. NASCAR versions used solid lifter cams with brutal 600 thousandths lift and 7,000 RPM redlines. These weren't street cams, not even close. 600 lift was astronomical for 1965. Modern engines barely exceed that. The valve springs were basically suspension coils, massive pressure to control those valves. The rocker arms were specially reinforced. Standard ones would break. The push rods were thicker than pencils, had to be. The forces involved were incredible. At 7,000 RPM, valves were opening and closing 58 times per second. The cam lobes were so aggressive they'd wear out lifters in one race. Teams carried spare cams to every event. Fresh cam for qualifying, another for the race, maybe a third for backup. The sound was indescribable, mechanical thunder. You could hear the valve train from a quarter-mile away. These engines were barely contained violence, but they survived. That's the miracle of the side oiler. A marine version powered high-performance boats, proving the engine's bulletproof oiling system worked under extreme G-loads. Boats present unique challenges for engines. Acceleration pushes oil to the back of the pan. Cornering sloshes it sideways. Jumping waves means zero gravity moments. Oil pumps can't suck air. Marine side oilers proved the system's brilliance. Even under brutal G-forces, oil reached the bearings. Offshore powerboat racers loved them. These weren't pleasure craft. Missiles that happened to float 100+ miles per hour across open ocean. The pounding was unimaginable. Regular engines would literally shake apart. The side oiler's bottom end just shrugged it off. Some marine versions made 600 horsepower, supercharged, intercooled, absolutely brutal. They'd run wide open for hours, crossing between Florida and the Bahamas. Mercury Marine bought the design rights in the 70s. They built marine side oilers for another decade. The design was that good. From Le Mans to offshore racing, it conquered everything. Number 5. The 427 also spawned the ultra-rare SOHC Cammer variant, though the side oiler bottom end was its backbone. The Cammer was Ford's nuclear option. Single overhead cam heads on a side oiler block. It was completely insane. 650 horsepower from the factory. 700 was easy with tuning. The heads were enormous. Chains driving the cams made it even wider. It barely fit in anything. NASCAR banned it before it ever raced. Too advanced, too powerful, too scary for 1965. But Ford built them anyway. About 50 complete engines, maybe fewer. They became drag racing legends, funny cars, fuel-altereds, top fuel cars. The Cammer dominated everything. But here's the secret. Underneath those space-age heads was a side oiler bottom end. Same priority oiling, same cross-bolted mains, same bulletproof rotating assembly. The side oiler design made the Cammer possible. Without that foundation, those heads would have been useless. The bottom end could handle anything the Cammer could dish out. Ford stopped mass-producing them by 1968 due to emissions and cost, But the design lived on in racing for years. The party ended fast. New emissions laws were coming, high-compression engines were doomed, insurance companies were refusing coverage. The muscle car era was ending before it really began. Side oilers were expensive to build. That extra machining, special casting process, hand assembly, Ford was losing money on everyone. They couldn't justify it anymore. The accountants won. Production ended, quietly in '68. But racers kept them alive. NASCAR teams hoarded spare blocks. Shelby bought everything he could find. Drag racers treated them like gold. The design influenced Ford's racing engines for decades. The Boss 429 used similar oiling. The 460 used lessons learned from the side oiler. Even modern Ford racing engines show its DNA. The side oiler might have died in '68, but its legacy lived on, still does. Only about 3,000 genuine side oiler blocks were cast, making originals extremely collectible today. 3,000, that's it, for one of the most significant engines in Ford history. Compare that to millions of small block Chevys, hundreds of thousands of regular FEs. The side oiler was always rare. Now it's approaching unicorn status. A bare block sells for $10,000. Complete engines, $25,000. $40,000 for date-coded correct ones. It's insane, but collectors pay it gladly because they're buying history. Each side oiler has a story. Maybe it powered a GT40 at Le Mans, or a Cobra at Riverside, or a Galaxy at Daytona. The provenance adds value. Documentation is everything. Factory build sheets, racing history, previous owners, it all matters. Fake side oilers flood the market. Conversions, reproductions, clever forgeries. But real ones? They're automotive archaeology. Finding an unmolested side oiler is like discovering buried treasure. Its Le Mans oiling breakthrough influenced later Ford V8s, setting the stage for decades of endurance engine design success. Ford learned something crucial from the side oiler. Priority oiling wins races. Every Ford performance engine since has used similar concepts. The Cleveland engines had priority mains. The 385 series big blocks incorporated the lessons. Modern Coyote 5.0s use advanced oil control systems, all traced back to the side oiler. Ford's NASCAR engines still use priority oiling, different execution, same philosophy. Feed the bottom end first. Everything else can wait. It seems obvious now, but in 1965, it was revolutionary. The side oiler proved you could build power and reliability. You didn't have to choose. That philosophy drove Ford racing for generations. Build it strong, oil it properly, win races. The side oiler started that tradition. Its DNA lives in every Ford performance engine today. The side oiler's design was so advanced that modern NASCAR engine builders still study it, and some of its oiling principles are used in Formula One engines today. This is the shocking part, a 60-year-old pushrod V8 influencing modern Formula One. But it's true. Priority oiling is now standard in all forms of racing. The side oiler pioneered it. Modern F1 engines use incredibly complex oil systems, multiple pumps, variable pressure, computer control. But the basic principle, same as the side oiler. Critical components get oil. First, modern NASCAR engines are basically evolved side oilers. Sure, they're fuel-injected now, different displacement, new materials, but cut one apart. The oiling strategy is pure 1965 Ford. Engine builders study original side oilers like religious texts. They're looking for secrets, trying to understand Ford's thinking. How did they know what would work? The answer is they didn't. They were solving problems as they arose. That's what makes the side oiler special. It wasn't over-engineered, it was perfectly engineered. Just enough technology to dominate. No more, no less. And there you have it, 20 shocking secrets about the Ford 427 side oiler that prove why this engine remains one of the most revolutionary power plants ever created. From its game-changing oiling system to its dominance at Le Mans, this wasn't just an engine, it was a statement. Ford took on the world and won with good old American ingenuity. Did any of these revelations surprise you? Which one shocked you the most? Drop a comment below and let us know. And hey, if you enjoyed learning about this legendary engine, smash that like button and subscribe for more deep dives into automotive history. Hit the notification bell too so you never miss our next revelation about the machines that changed the world. Thanks for watching, and we'll see you next time.